Welcome to 1.7 AP PreCalc, which is all about these inverses, and we know inverses are functions that undo each other. And they're so cool. They come in handy. We love using our inverses. A lot of times we even are using them without even knowing it. But let's go ahead and remind ourselves of some steps in terms of solving for our inverses. So one, of course, is go ahead, switch x and y. And technically, once you've done that, step one, you've done your inverse, right? You've now found your inverse. That's what they do. They switch those x and y's. But because we don't like just leaving it like that, we now need to go ahead, solve for y. And then if need be, you're going to write it in inverse notation. And that's that little, looks like an exponent, but it's not. So the inverse of f of x. So in this first example, we're actually going to go ahead, we're going to start with y. So y equals the square root of 2x minus 3. Step one, switch that x and y. So x is now equal to the square root of 2y minus 3. And again, if I threw this on Desmos, I'm done. But our graphing calculators can't do that. Your graphing calculator needs y isolated. So let's go ahead and let's do some inverse steps, such as we're going to square both sides. So now we have x squared is equal to 2y minus 3. I'm going to add 3 to both sides is equal to 2y. Divide by 2, so we get x squared plus 3 all divided by 2 is equal to y. All right, so this is pretty cool, and if you kind of think about it, right, this guy is our original function, and this is now our inverse. But if we remind ourselves of some, like, right, this function is going to look like this, but this function is going to be a parabola. No fun. Those are not inverses of each other, right? So let's remind ourselves that the domain and range of our original function is really important. The domain of this function is going to be 3/2 to infinity, and the range is going to be from 0 to infinity. And if you don't trust me, go ahead, throw it on a graph. You can look at it. But we now know, hey, in order to restrict our inverse, we're going to take the range. So we're going to go ahead, it's supposed to be a D for domain, so let's make that look like a D. Domain of this is now going to be 0 to infinity, and the range is going to be from 3/2 to infinity, which now makes this function look like half a parabola. So it would look something like this, which would be the inverse of our original function. So as a reminder, you want to go ahead, you want to flop those up for your inverse, right? So making sure that you're paying attention to your domain and ranges. Let's go ahead and let's try a rational function, because those do have a little bit of extra steps in terms of inverses, but they're fun because they involve factoring, and we love factoring. All right, we have a rational function here. We got x's on the top and the bottom. So we're going to go ahead and start by swapping x and y. And so I'm going to say x is equal to 2y minus 4 over 3y plus 8. I'm going to go ahead and actually fraction bust a little bit. 3xy plus 8x is equal to 2y minus 4. And if you're confused how I got there, I multiplied everything by 3y plus 8. So just as a reminder, you go ahead and kind of fraction bust that bottom. And then we're going to go ahead and I want to isolate y's, meaning I've got to move as many y's over to one side as I can, and anything without a y to the other side. So I have 3xy minus 2y is equal to negative 8x minus 4. And now we get to factor. So I have 3x minus 2 is equal to negative 8x minus 4. And when you go ahead and divide both sides, we get the inverse of f of x is equal to negative 8x minus 4 over 3x minus 2. Wouldn't quite have enough room in that box, but what we get there is that you want to go ahead and remind yourself that you do need to, right, get as many y's as you can over to one side, and then go ahead and factor out that y. That's the little trick with those rational functions in terms of finding your inverses. Okay, so that was a bit of a review, but we want to make sure that we talk a little bit about inverses in terms of functions, right? So if I use my first one here, I'm looking at my original function in blue, and I'm deciding if it's a function. Yes, this is definitely a function. But if I think about my inverse, and my inverse here would look something like, kind of reflected over this line, y equals x, right? My inverse is also a function. So it's pretty cool on this one. But if I now look at my function over here, yes, it's a function. It's a parabola, absolutely. However, my inverse of this is going to be kind of the sideways parabola, and it is not a function. That's not a function, right? Sometimes your inverses end up not being functions. So this is where it's kind of cool. You've all heard about the vertical line test, but if I go ahead and I talk about a horizontal line test, so I'm going to go ahead and just kind of draw a horizontal line here, and then I'm going to take mine and I'm going to move it down. So I'm going to just grab it for a second, and I'm going to move it down. And if you'll notice, I'm looking at my original blue function here, and it is not intersecting twice anywhere, right? There's nowhere here where it intersects twice, meaning it passes the horizontal line test. But if I take a horizontal line here, yeah, we're going ahead and we are intersecting it at this point and this point. So it does not pass the horizontal line test. So what we can say is, right, we have now the horizontal line test. You all used to the vertical line test. Horizontal line test, if a horizontal line can pass through a graph of a function, only touching it at one point, then the graph's inverse will also be a function. The fancy term for passing the horizontal line test is that a function is 1 to 1. Should be little hyphens in there. So a 1-to-1 function means not only will it strictly produce one unique output for every time for a given input, but it will also never, ever produce that output for any other input, right? Meaning that if you are given an output, you're only going to have one input to give you that function. This is pretty straightforward if you think about, hey, on this parabola, what's giving me an output of 4? Well, the input of 2 and the input of -2. That's two inputs that double up there. So that's not a 1-to-1 function, whereas a cubic is a 1-to-1 function. And as a reminder why we love our inverses and composites is that those composites, right, composites of inverses always equal x. That's how we prove that they are inverses. We can go ahead and use our composites. That's saying that the inverse of f of x is equal to x, and it works both ways, right? F of the inverse of f of x is equal to x. So some cool things about inverses and